So let's begin today's material. We will begin chapter 2.8 and 9.1. We will probably just start with 2.8. We won't go into 9.1. We will do 9.1 after our break. And if you remember 2.8 yesterday, 2.8, I mentioned that the only thing we asked you to do for this group of tests that you're about to do is to determine if it's a expression, determine if it's a equation or is it a inequality. Okay, so 2.8, the main thing in 2.8 is the next part of 2.8 will be on your next task will be how can we solve a linear inequality. So as we mentioned yesterday, in order to be an inequality, they need to contain this item right here. They need to contain one of this symbol, right? One of this item that you need to have is either less than, greater than, less than or equal to, or greater than equal to. So this is the only four symbolic that you will see, right? So how do we solve this? Or in our objective for today, the objective for today is if we have an inequality, and this is what I mentioned to you guys yesterday, is the difference between inequality versus the equation, or what is the main thing, or what is the main difference. If you look at the equation, here, the equation basically tells you to find x, to solve for x, to get x by itself. And if you get x by itself, then this thing just tells you that x can only take on one number. And what is that number? The x can only take on 7. Meaning, again, this is the only number that can represent x, is 7, right? Again, 7 is not this x, but I'm just saying that if we have an equation and we need to solve for x, and if you solve for x, you have some number, and the number that's tell you that we can only have one number to represent my x. Okay, the difference in terms of inequality is instead of just one number, we have a list of number, right? Looking at this thing here, we say x is less than 7. Well, what number is less than 7? Well, we know 6, 5, 4, 3, 2, 1, negative 1,000, meaning we have a range of number. And if we have a range of number, that's what inequality come in. So if we have a range of number, there are two additional things that we need to do other than solving, right? Our goal is we need to solve, we need to get x by itself. But the other two things that we need to do is we need to graph this item, okay? So the two additional things in 2.8 is we need to know how to graph your inequality, and you need to know how to write your solution in interval notation. Okay, so to graph this thing here, this is what they ask you, or they tell you, is to graph the inequality, we need a number line. Whatever your number line, which is again 0, 1, 2, 3, 4, negative 1, 2, 3, 4, and stuff like that. But this is the two new thing, or this is one thing you need to remember is if we are dealing with a less than or equal to, or greater than or equal to, if we're dealing with something that have a equal to, which is the equal line, then we have to include the endpoint. We need to include the endpoint, and to show that we need to include the endpoint, we need to use a bracket. If you saw this thing earlier, they might tell you that a open circle and closed circle as a notation, but now instead of open circle and closed circle, we're using this bracket if we see the equal sign. If there is no equal sign, we do not include the endpoint. And if we do not include an endpoint, we will use the parenthesis to illustrate that. Okay, so just to be in short, this is what you need to remember on top of everything else. On top of everything else is if you are dealing with this symbolic, you have to use the bracket. If you are dealing with this symbolic, you will use the parenthesis, okay? And the difference between the parenthesis and the bracket is tell you that you can include the endpoint. So that's one thing is to graph, which is, let's take a look at this item, and you all know how to graph this thing here. So if we look at this problem, I will mention more about interval notation a bit later, but let's take a look at the graph part. right? So let's take a look at this example here, which is I give you x is greater than 4. So for me, this is all you need to do to graph that. Your inequality is basically, again, you have your number line and you go to your endpoint, which is whatever this number is. It's -4, not 4, sorry. It's supposed to be -4. X is greater than -4. I look at this thing and I give you the wrong number. X is greater than -4. So basically, wherever your endpoint is at, you go to your endpoint and you ask yourself, at this endpoint, at this given endpoint, do I use the bracket or am I using a parenthesis? So as you can see, we have this item, which is we have a greater than or less than, which is in this case, we say x is greater than -4. Again, change it to -4, right? X is greater than -4, which is because of this symbolic, we will use the parenthesis. So at the endpoint, we will use the parenthesis. And the only thing left you have to do is, because we have a group of number, we need to shade it, right? Because any of this number is bigger than -4. Okay, -3 is bigger than -4 in terms of the value. -2 is bigger than -4. 0 is bigger than -4, meaning there are so many possibility that you can choose for x, and that give us that we need to graph them. So as you can see right here, the whole entirety on the right hand side of this number is bigger than -4. Okay, and to be in short, the interval notation is just basically tell you, instead of graph them, give me a list of number. Give me a list of number that I can choose that fit the description that x is bigger than -4. So if you look at this thing here, you can see that this is all you need to do is whatever the endpoint, all you need to do is, instead of put the endpoint on the bottom, we just put the endpoint inside your parenthesis. So this is my parenthesis, because why am I using the parenthesis? Because I cannot include the endpoint. So again, I cannot include a -4. And this thing will keep on going to the right, meaning it's keep on going and going into the positive infinity. So if you look at this thing here, you have two choices. If you go to the right, you will go to positive infinity. If you go to the left, you will go to negative infinity. Okay. You can buy the access code with You can buy the access code with MyMathLab, or you can buy the access code at the bookstore. I saw some student order the access code from the bookstore and they mail it home. So again, it's up to you. You have your choices. You can Google search and find the best deal if you want to. But again, you have to buy it either from the Delgado bookstore or on their website. Okay. So looking at this thing here, what happened if we have something? What happened if we have something like this, which is, do you agree that this is what they tell us? If we read from x, which is we're looking for a number x that is less than or equal to 7. So what number is less than or equal to 7, which is, do you agree that any number on the left-hand side of 7 is less than or equal to 7? And because it's equal to, we will illustrate that we can use 7. And to illustrate that we can pick 7, that's why we're using the bracket, okay? Why? Because 7 is equal to 7. That's true. It's a true statement. 7 equal to 7. 6 is less than 7 is also a true statement, right? Up here, 4 or -4 is not greater than -4, right? And that's why the difference between the parenthesis versus the bracket. The bracket tell me that we can include that number. Parentheses tell me that I cannot include that number. I can get close to it. I can get -3.99999999999999999, but I cannot get to -4. Okay. And again, same idea. Looking at this thing here, like I mentioned earlier, if you go into the right, if you shade it and go to the right, you will go to positive infinity. You start with your endpoint and go to positive infinity. If you go and you shade it to the left, you have to start with a negative infinity because you have to put the smaller number on the left-hand side, just like the number line. On the left-hand side is your smaller number, so your interval notation, you have to start with some small number. This thing will keep on going and going and going and going until negative infinity, some humongous negative number. And when does this thing stop? Well, it stops at 7. As you can see, we cannot pass 7 because any number, 8, 9, 10, those numbers are not smaller than 7. So the interval notation, this item right here, this is your interval notation. It just basically tell you to list them, but because it's so many number, I don't want to list individual number. I just group them together from negative infinity all the way to 7. Okay, so this is what we have. This is our inequality. This is our inequality right here. And our goal is we need to graph it this way. This is your graph. And we need to put them in interval notation, which is this is in your interval notation. One thing I know some of you will ask, or some of you will say, wait a minute, Mr. Tran, this thing here, we have a bracket. Why are we not using the bracket at negative infinity? Why do we use the parenthesis? Well, one thing, ladies and gentlemen, is infinity, negative infinity or positive infinity is just a figure of speech. We don't know that number. We don't know what infinity is. All we know is some humongous number, right? We don't have the exact amount. So we don't know what to include, right? So we don't know, we never, to be short, we will never include infinity because we don't know what that number is to include. So at infinity or negative infinity, you will always use the parenthesis. Doesn't matter what the other endpoint is, you will always use the parenthesis at infinity or at negative infinity, okay? And this thing will, you won't see this today, but this thing will be next week. If I give you I give you the wrong one. If I give you this item here, this interval notation, how would you graph this interval notation? Well, if you were to graph this interval notation, how about I say that all we're doing is, again, at negative 3, we have a parenthesis, and at 2, we have a bracket, and all we do is we shade it in between, meaning again, this is the group of number. This is the group of number that is bigger than negative 3, but smaller than 2. And my apology, this thing's supposed to be, I don't know when I type it is, this thing's supposed to be this. It's supposed to be negative 3, less than or equal to, not less than equal to, less than x, less than or equal to 2. Okay. Again, this graph is supposed to be this. It's supposed to be this item here. As you can see, if I were to give you this thing here, negative 3, do you see that negative 3, this is where my negative 3 come in. This is, if you read this thing here, you're looking for a number x that is bigger than negative 3, but smaller than 2. So what number is bigger than negative 3 and smaller than 2, which is, this is the group of number that is bigger than negative 3, but smaller than 2. Okay, so this is supposed to be the inequality. I don't know why I wrote the answer before I wrote the question. But again, the inequality, and if you were to have this, and if you were to have this graph, if you were to have this graph, if you were to have this graph, basically all you do is you say, well, on the left-hand side, I have a parenthesis. On the right-hand side, I have a bracket. That's why I can choose the 2, because the 2 is, I can choose 2 because 2 is equal to 2. And any number in between, those are the items we have, okay? And the purpose of this thing here is not always that you will go into infinity and negative infinity. You can have a set, a group of number, which is, this is your set group of number, okay? First of all, question. Well, if you don't have question, let's take a look at the next item. Let's put all of this together. And none of this thing here is on your test for this weekend or until next Monday. Let's take a look at this item. So this is your typical item in 2.8. Again, the previous one, I just want to show you how your graph should look like and how your interval notation should look like. Now, this is your problem, ladies and gentlemen, which is A, B, C, and D, right? And they ask you to solve, to graph, and to write your interval notation. So this weekend, when you, or tomorrow, when you do your test, the solving part is the same. The solving part is the same. The only thing we're dealing with is instead of the equal sign, again, just imagine that this is your equal sign, right? This is my equal sign right here, but we just basically leave it as it is. Your goal, whenever you solve, your goal is the same. Your goal is try to get X by itself. So how do I get X by itself? Well, nothing new. We know that we have the subtraction and a multiplication. To get rid of or to solve for X, we need to get rid of this subtraction first. We need to get rid of this one, right? And how do I get rid of this one? Well, if it's subtract, I need to add to the other side, right? If it's a subtraction on one side, when I move across the equal sign, I need to add. And if I add them, 7 plus 1 to give me 8. And how do I get rid of the 4? Well, if it's multiplication on one side, I have to divide. And in this case, when I divide, 4 going to 8, or 8 divided by 4 to give me 2. So as you can see, this is our goal. Our objective for solving is to get X by itself. The notation is a little bit different, but again, this is last time, or the homework for today, or your test material, instead of the less than sign, it's going to be the equal sign. Okay, so solving, we haven't done anything new. Solving is the same as before. But now, what do we have? We need to graph. How do we graph this? This is what you need to ask yourself. For me, on your homework, on your test, they give you the number line, so you don't really need to do it. But if you do it on your scratch work, for me, this is what I do is I have a number line, right? And where is your endpoint? The first thing you can ask yourself is, where is my endpoint? My endpoint is at 2. So I put a 2, doesn't matter where, right? It doesn't matter where, you just want to know where your endpoint. And at this endpoint, you ask yourself, are you using a bracket or are you using a parenthesis? And hopefully you say that there's no equal sign, there's no line, so we will use a parenthesis. And do we shade it to the left or do we shade it to the right? Which is, do you agree that any number to the left of 2, any number to the left of 2 will be less than 2? When you read this as X is less than 2, meaning you find me a number. Find me a number that is smaller than 2, but don't include 2, and that's where the parentheses come in, which is 1, 0, -1, right? We don't need to fill it in. We just know that anything to the left of 2 is less than 2. Anything to the right of 2 is greater than 2. So this is my graph, okay? So the first part, solving, is the same as before. You solve the same way you've been doing, get X by itself. The new thing is we need to graph them, which is identify your endpoint, and at your endpoint, do we use a parenthesis or bracket? And do we shade it to the left or to the right? Once you have this, to write your interval notation is basically, like I mentioned, if you shade it to the left, you have to start with -infinity, go to that endpoint, which is, again, because it's going to the left, -infinity, comma, to the endpoint 2, okay? So question here. I will show you the course ID after class. I will show you how to get there, or how to get the item before the class over. So looking at this thing here, first of all, question on how to graph, or how your graph should look like. Question on how your interval notation should look like. Any question here? Well, let's try B, right? So if you look at B, same idea, right? This problem last time, instead of this last time, instead of the inequality, last time is the equal sign. So if you have an equal sign, the book tell you this. The book tell you instead of working with inequality, you just change the inequality to equal sign. But you don't really need to do those. So looking at this thing here, this is what we have. How do we solve? Well, to solve, we need to get rid of the parenthesis, right? So looking at this thing here, we know that we want to get rid of the parenthesis, and to get rid of the parenthesis, we need to distributive the 9 in. And if I distributive the 9, do you agree that 9 times x is 9x? 9 times -3 is -27. -3x is the same, greater than or equal to 3 is the same. So everything that I did not touch is stay the same. I just bring it down. And again, looking at this thing here, my new problem is 9x minus 27 minus 3x greater than or equal to 3. And you can see, or hopefully you recognize that the 9x and the -3 is on the same side. And if they're on the same side, we do not do the opposite operation. We just treat them, whatever that operation they tell me to do, I need to do it, which is in this case, 9 minus 3 will give me 6. And my new problem is 6x minus 27 greater than 3. And as you can see, after 2 steps, we convert whatever this B problem is to something that we know what to do with A, right? We know that we need to get rid of the 27. And to get rid of the 27, if on this side is negative, I need to add it to the other side. And if I added 3 plus 27 to give me 30, and now how do I get rid of the 6? Well, if it's multiplication on one side, I have to divide to the other side. And to divide, 6 going to 30, or 30 divided by 6 is 5. So this is what we have. We solved this. We got the solving. It's nothing new. The look of it is new because of the less than or greater than, or less than equal to, or greater than or equal to, right? But so far, nothing we did was new. Okay, and that's what you do this weekend until next Monday. Okay, so the new part come in is how do we graph them? And like I mentioned to you guys, for me, draw a line, identify your endpoint. It doesn't matter. Doesn't have to be precise. You only need to know where is your endpoint, which is in this case, everybody see that the endpoint is 5. And now you need to ask yourself, at 5, at my endpoint, do I use a parenthesis or am I using a bracket? And hopefully you answer a bracket because there is an equal sign, okay? If you look at over here, there's no equal sign, so we use a parenthesis. There's an equal sign, we use a bracket. Okay, my bracket is a little bit small, but that's the bracket, okay? So looking at this thing here, do you shade it to the left or do you shade it to the right? Which is, again, we're looking for a number that is bigger than or equal to 5. So bigger than or equal to 5 is anything to the right. And that should give you an idea that if we shade it to the right, we have to start with the endpoint and we go all the way to the positive infinity. Make sure you know that if you shade it to the left, you have to start with infinity or negative infinity to the endpoint. If you shade it to the right, you start with the endpoint, go all the way to positive infinity. This item right here is your interval notation. And if you saw, I make a mistake. Yes, it's supposed to be a bracket, not a parenthesis, okay? Again, this thing here is supposed to be a bracket. So first of all, question would how to solve, how to graph, or how to write your interval notation. Question with this page here, example 2, A or B. All right, if you don't have question, let's take a look at C. So C, if you look at this thing here, C is identical to what we had before. And we see that we have a parenthesis on both sides. And if we have a parenthesis, just as always, we need to distributive them in. And if you distributive them in, do you agree that 6 times 3 to give me 18, 6 times 12 to give me 72, 5 times 3 to give me 15, and 5 times 9 to give me 45, right? 45 is supposed to be red, but you see the idea. And once we have, this is our new problem. And if you look at C and compare back to B, you'll see you have X on both sides of your inequality. And if X is on both sides of your inequality, we need to move it across. And if we move it across, we need to do the opposite operation. For B, they are on the same sign. And that's why I have the yellow color coded last time. But again, in this case, I moved the 15 over, and because I move it over, I need to subtract. And if I subtract this thing here, you all know 18 take away 15 is 3, which is 3x. And again, as you can see, this is our new problem, right? This is the problem that we all know how to do. How do I get rid of the 72? How do I get rid of the 3? Because I need X to be by itself. And to get rid of the 72, I know that I need to subtract, right? And again, if I subtract 45 minus 72 will give me a negative 27. And I need to divide. And if I divide this thing here, I have a negative 9. So looking at this thing here, solving. Hopefully you guys say, Mr. Tran, I got this, solving. Again, we've been doing the past 2 or 3 days, what we've been doing was just solving, right? They give you a different type of problem, but all we do is we try to get X by itself. So question with solving here, question of the steps, question of the procedure, question of how I got X less than or equal to negative 9. And the new thing in 2.8, the new thing is how do you graph? So to graph this thing here, we know that first we need to identify our endpoint, which is my endpoint is at negative 9. So at negative 9, do we use a parenthesis or are we using a bracket? And hopefully you guys say bracket, 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 right? Again, why are we using a bracket? Because there's an equal sign.
Equal sign.
Exactly, there's an equal sign. And that's why we're using the bracket, because we can include negative 9. And again, do I shade it to the right or to the left?
Greater than.
Less than, right? X is less than.
Oh yeah, X.
X is less than, so we shade it to the left, right?
Yeah.
So anything to the left is less than, and if you remember, if you were to write it in interval notation, because you shade it to the left,
it's negative infinity.
Right, comma, negative 9. And it's a bracket. It's a bracket right here. It's not the parenthesis. I don't know why I keep on writing the parenthesis. This answer is supposed to be a bracket. Same as the previous one. It's supposed to be a bracket, not the parenthesis. Okay. But again, let's take a look. Question with this here. Question on how to solve, how to graph, and how to write your interval notation. Is it hard? Hopefully you say not. Right? If it's hard, well, we still have a long way to go. We will do a few more in the process before you fully get. But again, let's finish this. Let's take a look at D. Right. D is the monster problem, right? Why is a monster problem? Because it's look monstrous, right? It's look so many steps. Again, as you see, no matter how big the problem is, right? No matter how big, this is big, massive problem. Your goal is somehow, some way, make it to this problem, because hopefully you know how to do A. You know to get rid of this 1 and to get rid of this 4. So how can we take this massive problem and convert it to this item? So we know, as always, there's a parenthesis, I need to distributive them in. And if I distributive them in, I can see, or hopefully you see, that 8 times 2 is 16. 8 times negative 5 is negative 40. 2 times x is 2x, and 2 times negative 7 is negative 14. Right? Whatever thing that I did not touch, which is the negative 13x, is stay the same. Negative 11 stay the same. So once I distributive, my new problem is this, which is, again, my new problem is this item. And looking at this thing here, I can see that my x, my 16x and my 13x, they on the same side. In addition, do you agree that negative 14 and negative 11 is also on the same side? And again, the reason why I put yellow is, again, because they on the same side, you do not do the opposite operation. You just do whatever operation they tell you to do, which is in this case, 16 take away 13, you have 3x, and negative 25, the reason is a negative 14 and a negative 11, that will give you a negative 25. So question, how can I convert this massive problem to something kind of a little bit familiar? And once you have this problem, hopefully you say, well, I can move my x. I can move my x to one side and let me move the 2x to the 3. So if I move the 2x to the 3, I have to subtract, which is 3x minus 2. And everything the same, which is, again, hopefully you say that 3 minus 2 is an x. And everything stay the same, which is x minus 40 greater than negative 25. We got to the problem that we know, right? We got to the problem that we know. We have some x minus some number. So again, your goal is take this massive problem to make it something easy. And hopefully you guys see that, again, from here, we need to get rid of the 40. And to get rid of the 40, I need to add, because on this side is subtract, I need to add. And even though I say we add, hopefully you guys recognize that we have an opposite sign. We have a negative 25 and a positive 40, which is, again, same side we add, opposite side we subtract, and kept the sign of the larger number. In this case, we know that x is greater than 15. 40 minus 25 will give me 15, and I don't need to do anything else because my x is by itself. Okay, so question, first of all, question of how to solve this thing here. Question on how to solve this item. And if you were to graph, hopefully you guys say my endpoint is 15, like doesn't, you know, some teacher asks you to write 14, 13, and 16, 17 over here. For me, it doesn't matter. All we know is we need the endpoint, and the endpoint is at 15. And we know at 15, we're using a parenthesis, right? And we're looking for a number that is bigger than 15, which is anything to the right is bigger than 15. So anything to the right, and if you remember going to the right, is basically you walk from left to right. The first number you enter is 15, and this thing keep on going and going and going and going, which is end up at a positive infinity. Okay. So question here, question with this 4 problem. Question with A, B, C, D here.
I have a question with the graphing. With the solving, I know everything, but what messes me up is the graphing part.
Okay. So for the graphing, first you need to identify your endpoint, right? So whatever this number that you solve, that will be your endpoint. If this number were to be a negative 17, you just put negative 17 there, okay? So that's the first thing, is whatever the number that you found, whatever your endpoint is, whatever this number, that is your endpoint. Yeah. The second thing is, now, once you have your endpoint, the second thing is you need to look at this item right here. You need to look at the inequality, okay? You need to look at this inequality. If it doesn't have an equal sign, which is in this case, it doesn't have an equal sign, right? If it's have an equal sign, we're using a bracket. If it doesn't have an equal sign, we're using a parenthesis. In this case, we don't have an equal sign, so we use a parenthesis. You agree?
That's what confused me. Okay.
So those are the 2 things. If you look at this thing here, if you look at this item, and again, my mistake wasn't do any help. But again, if you look at this 2 problem, this thing doesn't have an equal sign, right? This thing doesn't have the line underneath. And if it doesn't have a line underneath, we will use the parenthesis. Okay, if they have the sign underneath, which is this thing have the sign underneath, we will use a bracket. You see where I'm going down. And now the final item is, do you shade it to the left or to the right of the endpoint, right? That's the last item to graph is, do we shade it, the number to the left or the number to the right? Well, the easiest way to do is, if your x is on the left-hand side, ladies and gentlemen, if your x is on the left-hand side, whatever the inequality pointing at, that is where you shade it. Okay, I put that there again. If your x is on the left-hand side and your number is on the right-hand side, whatever the pointing, wherever this thing pointing, that is where you shade it. If you look at this thing here, if you look at C, this thing point to the left, we shade it to the left. This thing point to the right, we shade it to the right. This thing point to the left, we shade it to the left. If you're in doubt, remember, this is what we got, right? If let's go back, and again, I guess we can stop here for, if you go back to this here, I told you, if you look at A, you see that this thing pointing to the left, right? If you look at A, you see that this thing point to the left. That's why I shaded to the left. If you look at B, this thing point to the right. That's why I shaded to the right. So that is only happen if your X is on the left-hand side. So that's one way to, if you in doubt, just move your X to the left and tell yourself, well, my X is on the left-hand side. If the pointing is pointing to the left, I shade it to the left. If the pointer is pointing to the right, I shade it to the right. Everybody see that? That's one way, one easy way to see where you shading or how you graphing. Is that clear? Does that answer your question? Did I disconnect? Well, like I mentioned, ladies and gentlemen, like I mentioned, this is not on your test this weekend. This is the new material. We will do more of this next time or next week. So